Hello, I'm Dr. Ala, camera designer. This is Discrete Event Simulation. Welcome back to Lecture 21, Part B. We're going to continue talking about intermediate modeling and Model 7.1 from textbook, from Arena textbook. And we'll continue talking about entity-dependent sequences and also data requirements and availability. And we will discuss verification and debugging. So as you recall, we have this Model 7.1 of small manufacturing system that consists of 4 different cells, with cells 1, 2, and 4 having a single machine, and cell 3 has 2 machines, and it also has different type of machines because one of the machines is newer, and so it processes 20% faster. So we also looked at 3 different part types. So we had part type 1, part 2, and part 3. And the cell type, the processing types depend on the cell, as you can see for part, and also on the part. So you can see for different parts we have different type of triangular distributions, and also depends on the time that we visit the cell. For example, when part 2 visits the cell 2 first time, and then when it revisits it, it has 2 different triangular distributions, right? It has different sets of parameters there. So it's important to take that into account, and also notice that for cell 3, the parameters are for slow machine, and so that's why we modeled it as 1 as a factor time for the old machine, which is the second one, and 0.8, which was the first machine, which is a newer machine, speed up, the 20% speed up. So let's go ahead. We already modeled the cells processes in cells 1, 2, and 4, and now we're ready to model the process at cell 3. So let's go ahead and review that. So for logic for cell 3, we have the following. We again going to have a station and a route modules that very similar to those that we introduced in modeling the processes for cells 1, 2, and 4. But in the process module, we're going to have some differences. So again, the action, which is sees delay release, just like before, and the delay type is also similar as an expression as we had in cells 1, 2, and 4. But we're gonna have a set instead of the resource, and so in the resources subdialog we're gonna select type set, and the set name will be cell 3 machines, which we have already defined in a set as a set of resources that contains 2 machines, cell 3 new and cell 3 old. So the selection rule for the set, we're gonna choose a cyclical. And of course, you know, it's can be debated whether the preferred order might have been better choice, but the cyclical should work for this model. And importantly, when we select the machine for the specific entity, we're going to save an attribute for that entity called machine index. And the machine index will be either 1 or 2. And then we're going to have an expression for delay time, which will depend on this machine index. So we'll have the process time multiplied by the factor, which, if you remember, the factor time, so we're going to have the factor time, and that will depend on machine index. So if the machine index is 1, then the factor is 0.8 if entity gets the new machine. Otherwise, it's going to be 1. And so in textbook, there is also an alternative expression that avoids the need for the vector variable factor. So please don't forget to check the textbook for more details about that. And let's talk a little bit about the data structures because it's important. So my question is, why an expression for processing times at cell 1 rather than entity attribute assigned in a sequence as we will use in other cells? Well, the simple answer is we just want to show the use of the expression, and we could have easily treated cell 1 just like the others. So conversely, we could have used expression for processing times at cells 3 and 4, but there would be a problem with the cell 2. And that's important to realize because the part 2 visits cell 2 twice, and each time it visits it, it has different processing times. So for cell 2, we really need to change this for the second time so that the processing time is different, and that can be only done using the assignment in a sequence that I will demonstrate to you in a little bit. And again, this is a very small model, so the moral is please carefully think about your data structures that you define to model specific things because they do affect, or they do have effect on how valid the model is. And so when you look at the logic for exiting system, for exiting we also need to define a station, and this is needed so that we know we know where to send the parts after they're done processing at all of the cells. So we're going to define a station with the name exit system, and we also have the dispose module to dispose of the parts, and we'll select the record entity statistics so that we can get the statistics collected, and this will generate one of the outputs that we want, specifically the cycle time for the total time in the system for all different types that we define of the entities, which is specifically those that we want to know are part 1, part 2, and part 3. And so we don't need a separate record module here to collect cycle times. So let me go ahead and finish modeling this in Arena. So here's our current model 7.1 in Arena, and I'm going to continue building the model. So the next thing is to model cell 3. So what I could actually do is I could copy some of this, or alternatively I could build it one by one. So let me just build it one by one again, just to demonstrate how we can do that for cell 3. So this is going to be my cell 3 station, and so the name is going to be cell 3. And this type, of course, the station type is station, right? We could have choose a set, but that would be different. So there is no need for set here. So now, well, let me rename it more properly. Alright, so now the next thing after we did the cell 3 station is to add the process, and that's under basic process. And so this module, flowchart module process, we're gonna rename it, and this is gonna be cell 3 process. And so again, the action is going to be seize, delay, release, but the resources are going to be different. So I'm going to double click on resources, and instead of the type resource, I'm going to change that to the type set, and then under the set name, I can select cell 3 machines. And so again, only a single machine will be ceased. So the quantity will remain 1, but there's 2 machines in the set, so we need to save a specific attribute there. And the attribute that we're going to save is going to be the machine index. And selection rule, we're going to leave as cyclical, even though we could have used the preferred order, possibly, right? So again, you can discuss that, and there's more details in the textbook on that. So now that we did that, notice that it's very different from what we had in cell 1, 2, and 4 processes. But then we also will have a similar things, right? We're going to change right away units to minutes, and then the delay type is going to be the same, which is an expression. But the expression is going to be quite different, so we're going to right-click and then select build expression from the drop box. And that gives us the expression builder dialog. And so here what we actually want to do is build this expression that involves the process time, but it also uses the factor that we defined for different machines. So let's first find the process time. That's going to be under basic process variables, attribute, and then value, and then here we're going to have process time. And so now that we got the process time for the cell 3 process, we're going to also select multiply this, right? So we're going to multiply this by the factor that we had, and the factor was a variable. So again, it's under basic process variables, and then we select the variable and then current value, and then here we named it factor time, so we're gonna click on factor time, and then I'm gonna choose this, right? So we factor the time, and that depends on our attribute of machine index. And so attribute is of course under basic process variables, so we click on value of attribute and then select machine index here under the attribute name. And so that gives us our expression, which is process time multiplied by factor time, and then the factor time is indexed by machine index. So now that we took care of the cell 3 process, the next step is to route from cell 3. So I could either copy this, or alternatively I can just demonstrate how we can do that by pulling the flowchart from the advanced transfer. So here I clicked on advanced transfer, right? If you don't have it, you can attach it template by clicking on template attach, and then after that we could do route, right? So again, the process is already selected, so my route is going to be connected straight to my cell 3 process, and then I double click on the route and edit it. So the name is going to be route from cell 3. The route time is going to be changed by right-clicking on selecting the zero here, so it's default, and then right-clicking and then click on build expression, and that leads us to the expression builder dialog. And what I want is transfer time. So the transfer time was a variable, so again it's under basic process variables, and then variable current value, and under variable name I'm gonna scroll down to transfer time, and that builds my expression transfer time, which is exactly what I want. So the important part is also to change the units from the hours, as is indicated by default, to minutes, and then the destination type from a station to by sequence. And so again, right, we're almost done. We still need the exit logic. So let's go ahead and add the station as our exit station. So this is going to be my exit station, and I'm going to rename it So I name it exit system station. And also system. So exit system station, the station type is going to be station, and the name is going to be, let's say, exit system. Again, we still going to collect the statistics, so we check report statistics. And we also need a dispose, so we're going to connect to this station a dispose flowchart module, and the disposed is going to be renamed into disposed of part. Again, we leave the record entity statistics, and that will take care of different type of parts. For different type of parts, we're going to get the total time in particular. And so this takes care of some of the modeling, but we still need to come back to sequences. And the reason why I didn't do the sequences right away is because I first wanted to define different stations, and it will be easier for me to take care of the sequence of the stations. And so sequence is under advanced transfer. So if you scroll down in the advanced transfer panel, you can see a sequence data module here. And as you remember, we have part 1 process plan. That's a sequence for part 1. And this means that this is a sequence of stations that any part 1 type entity must go through. So right now it's 0 because there's no, you can see there's no steps or anything. So what we need to do is we need to add the steps here for each of the parts. So we're going to start with part 1, and just to review, this is the sequence for our part 1. Part 1 first go to cell 1 station, then cell 2, then cell 3, then cell 4, and then exit the system. So let's go ahead and model this. So to model this, in the steps dialog, we're going to double click and add stations. So notice when we start the sequence here, what is the next station for part 1? It's cell 1. So we're going to choose the corresponding station, right? And they're already been defined for us because of the modeling, right? So when I modeled, I already created those different stations, so I can just select them. So click on cell 1, and I can name this as a step. So my step name is going to be part 1, step 1. And the next step is going to be part 1, step 2. And in cell 1, we already had the times defined, right? Because we had cell 1 times as an expression, so we don't need to have any kind of assignments here. And the next one is a cell 2 station for our part 1 sequence. And so in the part 1 sequence, we're gonna have cell 2, and that's gonna be our part 1, step 2. And the next step is gonna be part 1, step 3. But for cell 2, we did not define the processing time, right? We used it, but it wasn't defined. So what we need to do is we need to define a corresponding process time. So let's review. So you can see that for part 1 in cell 2, these are the parameters for triangular distribution. we have 5, 8, and 10. So we need to define the process time with the triangular distribution of parameters 5, 8, and 10. So to do that, I'm going to double click on the assignment, and that pops here, right? And then here I can choose attribute. I could have also chose variable, picture, picture set, or some other at this point. And so I keep it as a default attribute, and then the name of my attribute, right, is not going to be attribute 1 as selected by default. I can scroll down to select the process time, right, because that's what I actually want to change. And in terms of the value, right, I could right click, so you can see I'm just right clicking here, and it gives me this drop down menu, and so I select build expression from the bottom there, and then what I'm gonna do is I'm gonna build the expression, which I need to use a triangular distribution. So scroll to random distributions, click on random distributions, and then scroll down to triangular. And in triangular, as we just looked up in the table, we need to select the values 5, 8, and 10. So 5, 8, and 10. And so that gives us the expression. So we can just say OK here. And then that populates this value. So if I extend it, you can easily see that's exactly what happened. And after I click close, this is going to change to from 0 rows for the cell to 1 row. And that's exactly what you see, 1 rows for cell 2. So we're going to continue. The next is cell 3. And so that's going to be the step 3 for part 1. And the next step is going to be part 1, step 4. And for cell 3, we also need the assignment for a processing time. And if we look it up, the processing time will be the triangular again with parameters 15, 20, and 25. So that's exactly what we're going to do. Again, clicking here, and my attribute is going to be process time, so I'm scrolling down to process time. And then here, instead of the value, I'm going to right click on it and then build the expression, find the triangular under random distributions, and then change the parameters to 15, 20, and 25. And now I'm done here. I can close. This is going to change this 0 rows to 1 rows. And the next is cell 4, so I'm going to click here and then scroll down to cell 4. Also change the step name to part 1 step 4, and then the next step will be part 1 step 5, so I added it. And notice the cell 4 also needs the processing time, so I'm going to double click on the assignment, change the assignment type, right, by double clicking, selecting the attribute, and then attribute name is gonna be process time. And then here I'm gonna build the expression, find the random distributions, triangular, and in triangular the minimum value for will be for our cell 4 will be 8, and then the most likely is going to be 12, and the maximum value is going to be 16. And just to demonstrate, that's exactly what we see here, 8, 12, and 16 for the cell 4 for part type 1, right, with a triangular processing time. So now that we built the expression for the cell 4 processing time, we're just going to click OK. So now this changes our attribute process time to this triangular value. And when I click here, close, then this changes from 0 to 1. And so last but not least, for part 1 is to go to exit system station. So I select here under station name exit system, and that's going to be my part 1 step 5. And here I don't need to assign anything, so that's it. And I can close this, and as soon as I close this steps, this is going to change from 0 rows to 5 rows. And so that's exactly what you see here. And so we're going to do the same thing for part 2 and part 3. So let's review part 2. So you can see for part 2, we're going to first go to station 1, then cell 2 station, then cell 4, then we'll return to cell 2, and then cell 3. So for cell 1, we don't need to assign anything, but for cells 2, 4, and 2 again, as well as 3, we need to make the assignments. And so after this 3, it's going to go to exit system. So let's go ahead and implement that in Arena. So to do that, I'm going to double click here right on the steps for part 2 process plan. So I'm going to click on 0 rows, and this brings me to the steps, and then I can be adding the steps here. So I'm going to start with cell 1, and this is going to be my part 2 step 1, and of course the next step is going to be part 2 step 2. I'm just editing some of this. Can extend it just to see it better. And the assignment is not needed for cell 1 because we already have cell 1 times. So the next station for part 2 is cell 4. So I'm going to select cell 4 here, and that's my part 2 step 2. And the next thing is the part 2 steps 3. And for cell 4, we need the assignment. So we're going to double click. We're going to change the process time. So attribute, and then under attribute names, I'm scrolling down to process time. And then here I'm going to edit it by right clicking and then build expression. And then it gives me the expression builder. And so in the expression builder, I need to use triangular distribution. So I scroll to random distributions, scroll down to triangular, and then added this according to the table that we just looked up. And in that table, it was, well, actually, let's see. I said this is cell 4, but this should be cell 2, shouldn't it? Let's double check. So in fact, it pays to double check, as the saying goes. So we do have, after cell 1, we do have cell 2. And so the cell 2 times are 4, 6, and 8. So let me edit that. So I'm going to set right away here to the parameters to 4, 6, and 8. And then say OK. So this is just the process time, so it's the same for all. But here it should be cell 2, so I'm going to change this to cell 2. But the next one is going to be cell 4, so I'm going to select this as cell 4. This is going to be my step 3 for part 2. And the next is going to be step 4. And for cell 4, we can also look up the values. The values for cell 4 are 15, 18, and 21 for triangular distribution. So see here 15, 18, and 21. And that's what we're gonna do in the assignment. So change the attribute to process time, and then under value I'm gonna right click, build expression, in the expression builder, I'm gonna select under random distributions triangular, and then I'm gonna have here, as I mentioned earlier, 15, 18, and 21. And so that takes care of the cell 4. And then we again gonna revisit cell 2, and that's gonna be my step 4 for part 2. And the next one is gonna be step 5 for part 2. And here we're revisiting cell 2 with the new parameters. So let's look up we can see here that when we revisit that cell 2 the second time, the parameters change to 6, 9, and 12. Right, so we need to change the process time to triangular with 6, 9, and 12. So that's exactly what I'm gonna do. I'm gonna double click here on assignment. In the assignment, I'm gonna double click, have the attribute as the default, and then select down in the attribute name to the process time, and then right click under the value to get the expression builder on the build expression, then select the random distribution and choose triangular, and then as I mentioned earlier, it's gonna be 6, 9, and 12. So I change the parameters to 6, 9, and 12. So now that I got 6, 9, and 12, I do OK, and also close this to get another row here. And then the next one is cell 3. So I'm going to select cell 3, and this is going to be my part 2, step 5, and I'm also going to have part 2, step 6 as the next step. And in assignment, I'm going to change the process time, of course. So my attribute name is going to be process time, so I'm scrolling down to that, and then use the expression builder, and here I'm going to choose my random distribution to be triangular, and I'm going to change my parameters to 27, 33, and 39. And so now we have 27, 33, and 39. And as you can see, that's exactly what we should have, 27, 33, and 39. That's what we should have in cell 3 as the parameters for processing time when part 2 visits it. And so the next part we're going to implement is going to be part 3 sequence. And the sequence goes as 2, 1, 3, and an exit system. So before we do that, we still need to do the exit system, of course, for part 2. So as I mentioned, this is good. So I do OK, close this, and add the final station, which is exit system. And this is going to be my part 2, step 6. And here I don't need any assignments, so this is good. Now, as you can see, I have 6 rows. So let's go ahead and take care of part 3. Double click here, add station names one by one. So first we're gonna have cell 2, and then we're gonna have cell 1, and finally we're gonna have the last cell, cell 3, and after the last cell we're going to exit the system, so it's going to be exit system station. And so here, right, I'm going to have the step names for my part 3, and here also for part 3, and here for part 3. And the final step is going to be step 4 for part 3. And so here also we can change in steps to next step and another next step and a last next step. And importantly, I need to change the assignments. So I need assignment for cell 2. So let's look up the time for cell 2. For part 3, when it visits cells 2, the triangular time has distribution 7, or distribution parameters 7, 9, and 11. So we're going to have 7, 9, and 11. So I'm going to double click here for the assignment for cell 2. Click on the assignment type, select the attribute, which is already selected by default. Then under attribute name, I'm going to scroll down to process time. And then for value, I'm going to right click on it to get build expression. So then on build expression leads me to expression builder. I'm going to choose random distributions, and then somewhere closer to the bottom there is a triangular, and so my values for the triangular is going to be 7, 9, and 11. And that's okay, and then close, and that gives us assignment for process time for cell 2, but for cell 1 we already have cell 1 process times as expressions, so we don't need any assignments. But for cell 3 we do, so we're gonna double click here, do assignment type, again attribute is gonna be process time. And in terms of the value, we're just going to build the expression. Again, we need to get to the random distributions, and then closer to the bottom there's triangular. And just to look it up, we can see that when part 3 visits cell 3, we have parameters 18, 23, and 28. And actually we did have 7, 9, and 11, which is great. So the next one is 18, 23, and 28 for the part part 3 cell 3 process time. So let's do that, and that's what we're getting, 8 for the minimum value, and then 23 as the most likely, and then 38 as the maximum. And then this works. And so we don't need any assignments for exit system, so all we need is just 2 assignments for cell 2 and cell 3. As I mentioned, cell 1 times have already been defined in the expression, so we're fine here. And so as you can see, we are done with the sequence, and that's very important. Just to demonstrate again, under the advanced process we had expression, and that's where we define the cell 1 times for all 3 parts, part 1, part 2, and part 3 here. So now that we have everything under control, we can check the model, right, by either clicking run check model or just running it. So again, no errors or warnings in the model. We can also observe the times if we run the model. But let's check whether the run control is set up to batch run. So we don't want any animation for now, so we can click on batch run, and then when the batch run is selected, as it is now here, we can run it very fast without any animation. And if it's selected to choose to see the results, this will give us a category overview for our model. And under entity, we can look at the time, which also includes this total time or cycle time. And so it gives us for part 1, the time, average time is 85 in minutes, of course, because this is base units, 85 minutes and 0.61, right? And then 112 minutes approximately for part 2 and approximately 66 minutes for part 3. So now we can also look at some of the utilization if we wanted to. For example, as you can see here, we could look at instantaneous utilization for different machines, and we have cell 3 new and cell 3 old machines, and we also have the utilization for cell 1, cell 2, and cell 4 machines. So now let's finish looking at the report at the moment, and let's close it. Let's also stop our simulation, and let's review what other things we could do. So as you saw, the model, we were able to run the model, and other things that we haven't really looked at was animation. And some of that animation I have already demonstrated in earlier models, so I'm not going to work it out. I'm not going to demonstrate much of it. Instead, I'm going to talk a little bit in terms of what we could do to take care of the animation. So to develop the animation, we could show the cues, and actually we already have the cues shown, but as you know, we can pull them out into a separate part, and we can define the views, different views for animation in the model. And by pulling the cues apart, we can also do some other changes, like extending the cues. We can also show the resources and also show the movement as well in the animate transfer panel, right? We just need to pull the animate transfer bar or select the animate transfer. So again, as I said, by pulling the animation away from the logic, we could take care of the animation. We could move, resize, reorient cues for realism, animate routes through using the animate transfer, and that will allow us to show different movement possibilities. And so to do that, we could use thick bundles of routes, use shift key and snap to the grid, hit clockwise direction, draw lines to define a route or lanes. Also in animation, we could import a drawing, for example, some AutoCAD drawing file as a backdrop, or resource pictures, and you can see more details about animation and how to do that in the Arena textbook. And we can also fine-tune resource pictures if you wanted to. We can add layers for seize point to, for example, when we have two machines in the cell 3, we could have two separate seize areas there. And in animation, if we did that, we could see that entities would travel at very different rates and pass each other. And so the question comes whether that's realistic. Of course, it's not quite realistic, but again, it's kind of depends on how we define things, right? So if you want additional realism for animation, you can check the additional information in the textbook, specifically in future modules or future chapters or future sub-chapters actually. And then let's now talk about the verification. It's very important for us to understand the difference between the validation and verification, because often these concepts are being mixed, but that is not correct. So when we building a model, we are basing it on the system, So either a system that already exists or a system that we're trying to design. And so there is often a question of whether a system is corresponding correctly to the model. And that basically is a question of validation. So the validation allows us to answer the question whether model is the same as the system. But verification is different. When we build a model, we introduce it through some type of code. So the model, mathematical model itself, is the thing that we are developing by coding it. So in Arena, we do it using visual coding, but if we did it in Simon, for example, or C++ or some other language, again, we would use a code as the code in that specific language. So in Arena, we do it visually, but it still creates this code. And so the question is our code corresponding to the model that we are trying to create, right? The type of mathematical model. And so the verification answers this question: is the code is the same as the model? And that also is corresponding to a debugging, or a part of it. Part of verification is to do the debugging, to finding whether there's any kind of changes or the code doesn't quite correspond to the models that we are building. And the truth is, we probably can never completely verify, and especially for large models. For simpler models, we might be able to, but for large model, it might be more complicated to figure out whether all that code that we constructed, whether it actually corresponds to the conceptual models that we are building. So the verification has several things that you can do, right, to do the verification. And some techniques to attempt verification includes eliminating error messages. So that's pretty obvious, and we have done it before. Sometimes we might forget something as we build the model, and then when we click check model, or when we click go to run the model, the error messages would remind us that we forgot to implement something or we missed something in the model. So eliminating these error messages is one of the way to verify, right, or attempt verification. But that's not it's not a foolproof method. It just does the things, right, that are obvious, but it does not check everything. So another thing is to look at single entity release and use the step through logic. So you can use the step through to see whether things are happening the way you would anticipate the model to behave. And you can also set the maximum batches as 1 in the arrival flowchart module. And you can replace part-time distribution with a constant as well, and that helps figuring things out, right? Easier to compute things, to see whether things are correct. You can also stress the model on extreme conditions. And another way to do verification is to do the performance estimation, and that's very similar to a slide rule decimal placement. And then we can look at the generated simon.mod and .experiment files. And so that can be done by clicking run and then Simon and then view. So let me show you. So here we could do run and then Simon and then view. And that actually produces, right, in the Simon language, it produces a coded file. And of course, you know, for a beginner, it might be a little hard to understand what really happens, but there's different steps that we go through, right? Starting with the create module, then going through assign, right? Then we have additional things under this module. For example, right, what happens, right, in terms of the assign. We have the following statements. And so all of this allows us to look at the assignment model file. So that opened assignment model file for us. So if you don't want to look at it, we just close this, right? And here, right, is additional file, and this is our experiment file. So we're going to close that as well, and that leads us back to the model. So this completes the lecture. So we're finished with lecture 12, both parts A and B, and this lecture is going to be really helpful. So please review it again and try to follow up and build the model with me as you watch the lecture again.